Here we have a set math problem. Okay, let's go to the question. In the figure above, O is the center of the circle. If the radius of the circle is 5 units, measure of arc BC is 60 degrees, then what is the area of triangle ABC? Okay, we have to find the area of this triangle ABC using the given information. Okay, now let me consider the given information. That is, the radius of the circle is given, that is 5 units. Okay, since the line segment AC passes to the center of the circle O, we can consider this AC as the diameter of the circle. So then OA is radius, that is 5, and OC is also the radius 5. Then the diameter of the circle AC is 10 units. Okay, now let's consider this particular piece of information. That is, the measure of arc BC over here is 60 degrees. Since the measure of arc BC is 60 degrees, the angle subtended by this arc BC at the center of the circle is the same angle, that is 60 degrees over here. Okay, by theorem, we know that the angle subtended by the arc at any point on the circle equals to the angle subtended by the same arc at the center of the circle. Okay, here let's consider the angle over here at point A on the circle. So this angle is subtended by the arc BC, and we can consider this angle 60 degrees. So this is the angle subtended by the same arc BC at the center. So the angle subtended by the arc BC at point A on the circle, that is this angle measure, is equal to half of the angle subtended by the same arc at the center of the circle, that is half of 60 degrees. So now to get the measure of angle over here at point A, we have to take half of this 60 degrees, that is 30 degrees. Okay, now let's consider the angle measure ABC over here, that is ABC. So this is the angle subtended at point B on the circle by the diameter of the circle. So if diameter subtends an angle at any point on the circle, always it will be a right angle. So here we have a right angle because at point B on the circle, this angle is subtended by the diameter AC. Okay, now we know that it's a right angle, that is 90 degrees in the right triangle at the vertex B, and at vertex A we have that the interior angle measure over here is 30 degrees. Then what must be the angle measure over here? Then it has to be 60 degrees. So that when I add the three interior angle measures of this triangle ABC, 30 degrees, 60 degrees and 90 degrees. So they all add up to 180 degrees. Clearly, ABC is a special right triangle, that is 30, 60, 90 special right triangle. Okay, in a 30, 60, 90 special right triangle, the side which is opposite to the smallest interior angle measure will be considered as the shortest leg. So BC is the side which is opposite to the smallest interior angle measure, 30 degrees. So BC is the shortest leg. Usually we assume X as the length of the shortest leg in a 30, 60, 90 special right triangle. And now let's consider the side AB of the same right triangle. Actually, this is the next longer leg because it is opposite to the next larger angle, 60 degrees. Okay, when I consider the X as a shorter length of the shortest leg, now to get the length of the next longer leg, which is opposite to 60 degrees, we have to multiply the length of the shortest leg X by square root of 3. So X times square root of 3 is the length of the leg AB. And AC is the hypotenuse of this right triangle because it is opposite to the right angle. So when I consider X as the length of the shortest leg in 30, 60, 90 special right triangle, the length of the hypotenuse has to be 2x. But already we know the length of the hypotenuse or the diameter of the circle AC, that is 10. So this 2x and 10 represent, both of them represent the same stuff. So we can equate them. That is 2x equals to 10. Let's divide both sides by 2. Then I'm getting 2 will cancel out. X equals to 10 divided by 2 is 5. Okay, now I got the value of x. Okay, here we can replace this x, which is being as the length of BC by 5. Okay, now I got the length of BC, that is 5. Okay, here we can replace this x times square root of 3 by 5 times square root of 3. So the length of the leg AB is 5 times square root of 3. Okay, so here, since ABC is a right triangle, so the two legs BC and AB can be considered as the base and height of the triangle. Okay, now we got the base of the triangle. Let me assume BC as the base and AB as the height. It's not like always this one has to be assumed as base. If you want, you can consider AB as the base and BC as height. So we'll be getting the same result. Okay, now let me assume BC as a base, that is 5, and AB as a height, that is 5 times square root of 3. Okay, now we can use a formula to get area of the triangle. Let me write it. Area of triangle ABC equals to 1/2 times base times height. So this is the formula to get area of a triangle. 1/2 times, okay, the base of the triangle is 5 units and the height of the triangle is 5 times square root of 3. Okay, now let's multiply this. 1 times 5 is 5, 5 times 5 is 25, 25 times square root of 3 is 25 square root of 3 divided by 2. Okay, now I got the area of the triangle ABC. It is 25 times square root of 3 over 2 square units. We find this stuff exactly in answer choice D. The correct answer choice for this question is D.